Welcome back to another study science video. Today we're going to be working on acids and bases. Alright, so what is an acid? Well, an acid falls on this pH scale right here. It's basically just something that wants to donate one of its hydrogens. So see here we have an example of H3O, and what that wants to do is donate one of its hydrogens to become H2O. And for the base side, a base wants an extra hydrogen. So if it gets an extra hydrogen, it would also become H2O. So what is pH? Well, pH is basically just the molarity of the acid in the solution. Remember, molarity is just M equals moles per liter. So for example, anything with a pH of 7 is just going to be 1 times 10 to the negative 7th power molarity. So that would be a molarity of 1 or 0.0004567, and that's moles per liter. So remember, if something has a pH of 7, it has a molarity of 1 times 10 to the negative 7th. This is just because pH is based entirely on molarity of the acid, or basically just the concentration. So if we know the molarity, we can find the pH. And the way we would do that for an acid is just negative log of the molarity of the acid, which would give us whatever the pH is. And then if you'd like to find the pOH, or the concentration of base, from that, you would just subtract 14 and the pH. And that would give you both the pH and the pOH. And then from there, you could find the molarity of both the acid and the base. So, for example, if we have 3.22 times 10 to the negative 4 molarity, to find the pH, we are just going to go negative log 3.22 times 10 to the negative 4th, which should give us an answer of 3.492144, repeating. So we have our, I'm just going to keep it in the sig figs of 3, so that is the same thing as 1 times 10 to the negative 3.49. Okay. And then if we would want to find our pH from that, we're going to do negative, or 14 minus 3.492 to get a pOH of 1 times 10 to the negative 10.51. But what does that mean for molarity? Well, for molarity, to find the molarity of this substance, we would simply do 1 times 10 to the negative 10.51, which should give us a molarity of 3.090 times 10 to the negative 11th power. But say we wanted to find the pH, that should be pH of something that is a base. Well, we would do the same equation, except we need to remember that we are taking the pOH first. So this log of the base is just, it's the base, it's not the exponent. It's going to give us the pOH instead of the pH. So, for example, if we have 4.32 times 10 to the negative 12 that is going to give us a pOH of negative log times 4.32 times 10 to the negative 12th is 11.3645165. So I'm just going to write that as 11.36, which, remember, is just the same thing as 1 times 10 to the negative 11.36. And then from there we subtract 14 and 11.36 to get our pH of 2.64. And what that means is basically, so on the pH scale, if this is here, that would mean for pH it's also there, but it's kind of flipped. So like on the pOH scale, base is here, acids here. That would be here on the pOH scale and here on the it would still be basic is what I'm saying. All right, let's move on to the nomenclature of acids. So there's two main types of acids. There are binary acids and oxyacids. And the way we name these is essentially, if it is a binary acid, it's going to always have the prefix hydro. And then if it's an oxyacid, it won't have that. So for example, this is a hydrochloric acid, and this is a nitric acid. Remember, when we're naming these acids, we always want to have the suffix of acid at the end, just to understand that they are in fact acids. Alright, so let's go over some of the weird rules. So for binary acids, you're always going to change the anion, or the, for example, for HCl, the anion would be the chloride. You're always going to change, if the anion is "ide," you're going to change it to "ic." And then you're always going to have the suffix of hydro. So for example, since this is chloride, it would be hydrochloric acid. And then it's pretty similar for oxyacids, obviously without the suffix. So if something ends with "ate," it's going to be changed to "ic." If it ends in "ite," it's going to be changed to "us." So for HClO3, since ClO3 is chlorate, it's going to be changed to chloric acid. If it was ClO2, which is chlorite, it would be changed to chlorous acid. So for these three example problems, we have find the pH of acid with molarity 3.07 times 10 to the negative 5th. And then going off our answer for that, we're going to find the pOH of that acid. And then finally, it might be hard to see, but that says name HNO3, with HNO3 being nitrate. So to start off our first problem, we need to find negative log of 3.07 times 10 to the negative 5th. Remember, because it is 10 to the negative 5th, that likely means it will be an acid, since it has a stronger concentration. And on the pH scale, it would be closer to the acid side. So for that, our answer would be 4.512. And rounding, it would be 4.51. And then to find our POH of that, remember we're going to subtract that from 14 to get an answer of 9.49. So on our pH scale here, that would be 4.5 away from 0 and 9.49 away from the base of 14. So that's going to be what we get. Remember, for pH, it's going to be going this way. You are becoming less acidic. And then for POH, going this way, you are becoming less basic and more acidic. Okay. And then for our last problem, it is name HNO3 with NO3 being nitrate. Remember, since this is an oxyacid, we don't need the hydro. And since it is nitrate, it's going to be changed to nitric acid. And that's going to be it. Thank you for watching.